Hi friends, I am Adarsh. I am studying Bachelor of Engineering in Venkateswara College of Engineering. Today we discuss about the digital signal processing subject. Today we discuss about the classification of signals. One of the topic in the subject digital signal processing. Let us come to the topic classification of signals. Continuous time and discrete time signals. Deterministic and non-deterministic signals. Even and odd signals. Periodic and aperiodic signals or non-periodic signals, energy and power signals, real and imaginary signals. Let us know individually detail about the signals. Continuous time and discrete time signals. Continuous time signal is said to be continuous when it is defined for all instant of time. In waveform we can see the continuous time signal, and the discrete time signal is said to be discrete when it is defined only discrete instant of time. In waveform we can see individually it is represents. And deterministic and non-deterministic signals. A signal is said to be deterministic if there is no uncertainty with respect to its value at any instant of time, or signals which can be defined exactly by a mathematical formula are known as deterministic signals. By mathematical formula we can waveform can form, and in figure we can see the waveform. And non-deterministic signals. A signal is said to be non-deterministic if there is uncertainty with respect to its value at some instant of time. Non-deterministic signals are random in nature, hence they are called random signals. Random signals cannot be described by mathematical equation. They are modeled in probabilistic terms. In figure we can see the non-deterministic signals. Next, even and odd signals. A signal is said to be even when it is satisfied this condition x of f is equal to x of t is equal to x of minus t. For example, 2t, t4 of cos theta, etc. Let x of t is equal to t2, x of minus t is equal to minus t of 2 is equal to t2, that is equal to x of t, and t2 is a even function. A signal is said to be odd when it satisfies the condition x of t is equal to minus x of minus t. For example, t, t3 and sin t. Let x of t is equal to sin t, x of minus t is equal to sin of minus t, that is equal to minus sin theta, that is equal to x minus x of t. The sin theta is the odd function. Next, periodic and non-periodic signals repeat at fixed intervals and have a smallest possible time period called the fundamental period. For example, periodic signals include sinusoidal signals, square waves, triangular waves, and sawtooth waves. In figure we can see the sinusoidal waves. Like that, periodic have square waves, triangular waves, and sawtooth waves. And non-periodic signals, also known as aperiodic signals. These signals do not have a fixed pattern or repetition. They are spread out over a range of frequencies. For example, non-periodic signals include speech waveforms, random signal. The speech waveforms and random signals are the non-periodic signals. They have no definite shape. Next, energy and power signals. A signal is said to be energy signal when it has a finite energy. The condition is energy is equal to some integration minus infinity to plus infinity x square of t into dt, and signal is said to be power signal when it has a finite power. Power p is equal to limit t extends to infinity 1 by t to integration minus t to t x square of t into dt. Next, real and imaginary signals. A signal is said to be real when it is satisfy the condition x of t is equal to x star of t, means conjugate of t. A signal is said to be odd when it satisfy the condition x of t, odd or imaginary, x of t is equal to minus x conjugate of t. For example, if x of t is equal to 3, then x conjugate of t is equal to 3 conjugate, that is equal to 3. Here x of t is a real signal. If x of t is equal to 3j, then x of conjugate of t is equal to 3j conjugate, that is equal to minus 3j, that is equal to minus x of t. That is a imaginary signal. These are the classification of signals. Thank you friends.